is a problem-solving question, and we're still going to work with radicals. We've got to do a couple other things on top of that, but let's read through this first and then pull out important. So we've got a chessboard, has squares that measure 2 by 2. The diagonal of the chessboard is the square root of 800, which essentially I'm just saying this, right? I just couldn't put it in there. How many small squares are on the board? So let's kind of try to give ourselves a visual if we can. Pull out a square. Yeah, chessboards are squares. Okay, so we know some information about squares. They've told us that the diagonal across is the measurement of the root of 800 centimeters. They want to know how many squares are on the board, but we, in order to do that, we want to find out how many there are in terms of a length and a width, because then we can kind of just multiply the length times the width to figure out how many squares.
Oh, I get it.
So we got to figure out how many there are across from each other. Okay, so we got to find out what these measurements are. Luckily, because this is a square, that means this side and this side are the same length, which makes this an isosceles triangle. And because it's a square, this is a 90-degree angle, which means we can use Pythagorean's theorem to kind of tease out or figure out what the measurements of these two sides are. Okay, so Pythagorean's theorem is usually stated as c squared, or the hypotenuse squared, is equal to the equivalent of both legs squared, or they usually call it a squared and b squared. Yeah. Okay, so we'll call this side A and this side B. It doesn't really matter. We'll call the hypotenuse C. Now, because it's an isosceles triangle, A is equal to B, so that helps us out a bit. I can replace the letter B with A, and it's going to make absolutely no change in our equation here. So C squared is equal to A squared plus A squared.
2A.
Yes, exactly. So if you think of it like there's a 1 in front of both of these, okay, and we're going to add them together, so we get 2A squared is equal to, and our C, well, we actually know what the measurement of C squared is. The measurement of C is 800, or the root of 800. So root 800 squared is actually just the number 800. The two cancel each other out. So think of it like this. 800 squared. These two are opposite operations. Okay. So we're left with 800 is equal to
2A.
2A squared. More time, just so it's a little bit clearer here. This value.
Because you didn't write it in, so then you wrote it down.
Yeah, I kind of jumped through it. Let's
Okay.
do it again. So the idea of C here, C is being replaced by the root of 800. So I'm going to say root of 800, but that's only C. And in Pythagorean's theorem, it's C squared.
Mm-hmm.
So this root and this square are opposite operations, so they disappear, they cancel each other out. So we're left with 800 now. So this is a lot easier to work with.
Yeah.
First thing we're going to do is divide by 2, right? Because it's multiplied on this side. When we bring it over, it will become division. So we're left with 400 is equal to A squared. And we already said above that the opposite of the power of 2 would be the root 2, so we need to do root 400. Well, that's not going to give us a very nice number. Okay, root 400.
It's 20. So it's perfect.
Oh, yeah, you're right. It is 20. Sorry, I was thinking of 4,000. Great. So 20 times 20 is, there we go. So 20 is A. So the measurements here. We've discovered that this is 20 centimeters, and this is 20 centimeters. And we got to take some other information. They told us that our squares were 2 by 2. So in other words, this would be 1 square. That's 2 centimeters, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. How many does that give us across here? How many squares?
10.
Yeah, the idea is that we're dividing 20 centimeters by that 2 centimeters, okay? So we have 10 squares here, and because it's a square, we have 10 squares here. So to figure out how many are on the board, we're looking at 10 by 10.
100.
We got 100 squares. Okay? It's not the easiest thing to kind of just piece out yourself. There's quite a bit of work to that, okay? But that would be the process. It always helps when you draw visuals of something. It helps it make a little more mathematical sense.